Hello, I welcome you all to this another interesting screencast. The problem reads: determine the maximum speed at which the car with mass M can pass over the top point A over the vertical curved road and still maintain contact with the road. If the car maintains this speed, what is the normal reaction the road exerts on the car when it passes the lowest point B on the road? This problem is coming from the Engineering Mechanics and Dynamics, 14th edition by R.C. Hibbeler. Right, we have been asked to determine the speed, okay, the maximum speed at which this car can pass over the hill at A and still maintain contact with the road. And then at B, we have been asked to determine the normal reaction that the road exerts on the car when it passes the lowest point at B, okay, while maintaining the same speed that the car had when it was at A. So let's draw the free body diagram. I'll need to get the same car. I'll get the same car. Let me just have it sniped. Okay, like so. Right, and then let me rotate it just a little bit. Okay, like so. Then let me collect it. I put it here. This is A. Right. At A here, let's draw the free body diagram. Let's draw what is happening. So we are going to have the weight. Of course, we expect the normal force like so, but I'll explain really what is happening. This point is A, that is point A, that point is A. Okay. That point is A, but I'll need another one. So let's say the car at A. What is happening there? For the car at A, we apply the summation of forces. We apply the summation of forces in the Y, in the N. So say summation of forces in the N, going down being our reference positive, this is just equal to M A N. Okay, where A N is just equal to V squared divided by rho. Okay, what do we have? We have W minus N equal to W minus N equal to M A N, which is also just equal to M V squared divided by rho. Therefore, this is Na like so. So making Na subject of the formula, this just becomes W, which is just mg, and we can factor out the m. So m, we have g like so. Then once this comes this side, it will just becomes minus, then this just becomes v squared divided by rho. Okay. So this is the equation for the normal force at A, but there are going to be three conditions. Okay. There are three cases. There's one case where this vehicle at a certain speed, it will not be touching the surface. The second case will be at a certain speed, it will be at the verge, okay, of almost losing contact. Then the third case is where it will be completely in contact, right? So when Na is less than 0. This means when it is less than 0, it means the car is not in contact with the surface. Okay, at this point, when it is less than 0, it means the car is speeding, it's flying. It comes here, it will just fly off. Okay, then we have this case, NA equal to 0. This is where the car is at the verge of losing contact with the surface. At this point, NA equal to 0, the car is still in contact, but it is at the verge. Alright. Then we have NA greater than 0. Okay. The car is in contact with the surface. So these three cases. Therefore, for us, we want the maximum, and for us to find the maximum, we need to use this. Okay. So we need to use this one. Okay. So writing this just becomes 0 NA equal to 0 will just be equal to mg, okay, minus mv squared divided by rho, right? Then m and m goes, right? Then our v squared just becomes equal to rho g, right? Then we can square both sides. To square both sides, we have this, and therefore our v will just be equal to square root of rho g, which we can just copy this. So square root of rho g, which is just this one here. Okay, so this is the maximum speed. That the car can move, okay, with mass m and still maintain contact with the rod. Okay, right. So found this. So using the same speed, let's find the normal force at B. All right. Let's find the speed at B. So we'll say car at B. So what happens at B? At B, we apply the equation again, summation, okay, summation of forces in the n direction, going up being our reference. This is just equal to MAN. where we already know what an is. It's just v squared divided by rho. So what do we have there? It will be n b minus w, and this is just equal to m v squared divided by rho. Our nb therefore is just going to be equal to m v squared divided by rho plus mg, right? So we already found v, and we said v is just equal to square root of rho g. So let's replace this in there. So nb will just be equal to m square root of rho g squared divided by rho plus mg. Therefore, our nb will just be equal to m rho g divided by rho plus mg. So rho and rho goes. Therefore, nb will just be equal to 2 mg, right? 2 mg. Okay, I think this is about it. We have found the normal reaction the rod exerts on the car when it passes the lowest point B, alright, and we found the maximum speed at which the car with mass M can pass over the top point A of the vertical curved rod and still maintain contact with the rod. Right, I guess we are done. Let me just make mention here to say the rho here, where rho is equal to R. Okay, I think we are done. I hope this particular video was helpful. Let me just outline this. This is our solution for the first case, and then we have the normal reaction for the second case, like so. Alright, so I hope this particular video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and I'll see you in my next screencast.